Hi everyone! In this video, pag-aaralan natin kung paano mag-solve ng material balances involving reactions using the third method, which we call species balance or molecular balance method. And here we will have an example that involves a bioprocess, specifically acetic acid production using fermentation or continuous fermentation. But before that, let's discuss a little bit about this method and how do we use this method later on in the problem. Basically, remember your material balance will have this equation or general formula that you can see in the slide. So you have moles input plus moles generated equals moles output plus moles consumed plus moles accumulated. So that is if you're using moles, pero pwede mong gamitin syempre yung ibang unit like grams or kilograms. Now, ito yung general balance equation, right, for material balances. This is true for both non-reactive and reactive processes. Okay? Normally, kapag non-reactive yung process natin, mawawala si generated, mawawala si consumed. Okay? And importante na maintindihan natin na kapag ang isang process ay nasa steady state, ang ibig sabihin nun, hindi nagbabago yung properties ng system, okay, from beginning to end. In that case, ang consequence niya is there will be no accumulation whatsoever of any species within the process. So again, if the process is in steady state, we have to let go, okay, of the accumulation term. Okay, so magiging zero si accumulation for steady state. Going back to my statement kanina, kapag non-reactive or physical lang yung process, usually input equals output lamang tayo. But for reactive processes, you will have two additional terms. So on the left-hand side of the equation, meron kang additional na moles generated, and in the right-hand side is moles consumed. So ano ba itong mga to? So isa-isahin natin. Let's start first probably with yung ating moles input. So ano ibig sabihin ng moles input natin? Okay, so si moles input, okay, siya yung molecules or compounds or substances, species that enters through the system boundaries. Okay, so kung ano yung pinasok, yun yung input. So madali lang intindihin, right? Now, ano naman tong generated? So sa generated or moles generated, ito yung mga species na produced within the system, or rather the amount of that species produced within the system. So hindi ibig sabihin na yung moles generated siya yung lalabas ng system. Okay? Ibang usapan yun, yung moles output, right? But for moles generated, na-produce siya within the system. Okay. Now, yung moles output, siya yung mismong lumalabas from the system. Species that leaves the system boundaries. And lastly, si moles consume, ang ibig sabihin naman yan is siya yung species and its amount, right, that build up, that uh, are consumed basically within the system. Okay, so if it's a reactant, basically makukonsume siya. Pero hindi ibig sabihin yung amount na na-consume ay yun na rin yung amount ng input mo. Okay? And of course, yung accumulation na kinancel natin dito, which is zero for steady state processes, basically, ang ibig sabihin lang niya is yung nagbi-build up within the system boundaries, or within the system rather. Okay? Now, a good thing about the molecular balance method is that its species balances, no, these species balances are always independent. In other words, among the three methods, siya yung pinaka magagamit natin. As I've mentioned before in my previous lectures, di ba, if there are three methods, students usually find it easy to utilize yung atomic balance method. Okay, mas gusto nila yung atomic balance, mas madali daw. However, yung atomic balance method tsaka yung extent of reaction, hindi, sometimes may mga problems na hindi nila kaya ma-solve. So, we have here this third method, and this particular methodology, kayang-kaya niyang ma-solve ang kahit anong material balance problem. Okay? So, it's always independent. So, personally for me, I find it more favorable and easier na gamitin itong method na ito. So let's go to our example right away. Okay? So in our example here, which is fermentation process, no, meron tayong Acetobacter aceti bacteria, which converts ethanol to acetic acid under aerobic conditions. Okay, so let me highlight that, no, aerobic Okay, one moment. Anyway, so a continuous fermentation process for vinegar production is proposed using non-growing Acetobacter aceti cells immobilized on the surface of gelatin beads. Air is pumped into the fermenter at a rate of 200 gram mole per hour. Okay? The production target is 2 kg per hour acetic acid, and the maximum acetic acid concentration tolerated by the cells is 12%. What is the minimum amount of ethanol required? What minimum amount of water must be used to dilute the ethanol to avoid inhibition? And third, let's calculate or determine the composition of the fermenter off gas. Okay, so let me explain a little bit about this problem. Okay? So, si fermentation, okay, probably isusulat ko muna yung ating pinaka balance equation or reaction. Okay? So, si fermentation daw, okay, you're utilizing ethanol. Okay? Yung cells na yon, ethanol daw yung kanilang carbon source. So, C2H5OH. Alright? And aerobic daw yung process. So, of course, meron tayong oxygen. And then, ang fermentation na to, it will form acetic acid. So, probably, gagamitin na itong process na to to produce vinegar, right? And then meron kang water, of course. Kasi kapag vinegar, of course, naka-solution siya. Ibig sabihin, hindi mo makukuha yung acetic acid as is, but rather it should be in the solution. Okay, so that basically is the reaction for the fermentation process. Now, let's put here the molecular weights needed sa mamaya kasi kailangan natin ng mga molecular weights. So for ethanol, that's 46. Okay, and for oxygen, so sabihin natin 32. Yung kanyang molecular weight. Acetic acid is 60. And si water is 18. Okay, now, sabi dito, since aerobic siya, kailangan mong mag-pump ng air dun sa ating fermenter. So, gaano daw karaming hangin ang ilalagay natin? So, 200 gram mole per hour. So, gram mole or mole, pares lang yan. Okay? And the production target is 2 kilograms per hour. Okay, so imagine you have the demand annually. If they convert that to per hour basis, so in every hour, dapat 2 kilogram daw yung ma-produce na acetic acid. And another thing here is that yung maximum acid concentration daw na tolerated by cells is 12%. Okay? So bakit 12% yan? Two things. Number one, gaya ng sinabi sa problem, pwede kasing magkaroon ng product inhibition. And it's true for many fermentation processes. No? For example, if we have ethanol fermentation or ethanol formation utilizing glucose, for example, yung ethanol, may inhibit niya, okay, which is the product, ethanol, may inhibit niya yung ating cells, okay, na ginamit dun sa fermentation. So, product inhibition ang tawag doon. So, ganoon din in this example. Yung acetic acid mo, hindi pa pwedeng sobra-sobra yung concentration at the end of the process kasi pa pwedeng ma-inhibit niya yung cells. Yung cells, kailangan gamitin mo pa siya later on, right? So, That is the reason. Pangalawa siguro, syempre, of course, di ba, nalilimit ng, we have limitations on the concentration of your acetic acid. Although you can dilute naman yung product natin later on. Okay. Now, let's proceed and let's probably draw the diagram first. Okay. So we have a, okay, let me draw sort of a, okay, at least that. Sabihin natin ito yung ating fermenter. Okay. Or reactor, basically. Okay. Okay, so we have here the feed. And then product. Sabihin natin P, yung product, and F naman yung ating feed. Okay, now, may papasok dyan na air according to the problem kasi nga aerobic siya. So air, ang amount niya ay 200 gram mole or 200 mole per hour. Okay? Let me probably write that in a different color. Oops, sorry. $200 mole per hour. Okay. Yung ating product, sabi sa problem, 2 kilogram per hour daw yung target na production. 2 kilogram per hour. Okay? And, sorry, 2 kilogram per hour acetic acid. So let me abbreviate yung acetic acid bilang AA. Okay? So 2 kilogram per hour acetic acid yung production. Hindi 2 kilogram per hour ng buong product stream. Pero again, may limitation. So dapat, sabi nila sa problem, 12% yung acetic acid. So this is a mass, no? So these two here, yung production rate tsaka yung percentage ng acetic acid or concentration ng acetic acid, these are the targets. Okay? So ibig sabihin, we are just designing a fermenter. Kumbaga, if these are your targets, yung amount ni acetic acid tsaka yung concentration niya, parang iniisip natin, gusto natin i-calculate, gaano kadaming feed kaya ang kailangan natin ilagay. Okay? So ganoon ang pagde-design ng isang process. Now, of course, since nagpasok ka ng air, you will expect na meron diyang off gas na lalabas. Ibig sabihin ng off gas, kung ano yung gas na matitira. So off gas. Sabihin natin G. Okay. Now, ano yung composition by the way ni air? So we know that the composition of air is oxygen and nitrogen. Okay? And we also know that oxygen is 21% and nitrogen is approximately 79%. Okay? So approximately, si air is 21% oxygen and 79% nitrogen. Now, yung off gas, ano yung composition niya? So ganoon din, meron kang oxygen, meron kang nitrogen. Okay? Now, let's solve this problem and let's utilize first a certain basis. So ano ang magandang basis sa problem na to? So for this problem, let's have probably 1 hour operation as our basis. Kasi continuous process siya. Usually kapag continuous yung process, ang nakalagay na streams, no, or na flow ninyo ay in terms of rates, no, mass flow rate, molar flow rate. Kaya nga may per hour tayo. Unlike kay batch process na yung kilogram or your moles mo na pinapasok or lumalabas, naka per batch siya, hindi siya per hour or per minute or whatever. Okay, so this is our basis 1 hour operation. And alamin muna natin yung ating ibang given. Ibig sabihin, baka may mapala tayo for each stream. Maybe there are other information na we can come up with. Okay? Kung mapapansin nyo dito, sa ating flow sheet or sa ating problem, walang given na yield or selectivity or conversion. Bakit? Kasi hindi pa nangyayari yung process na to, nagde-design pa lang tayo. Basta ang target natin yung 2 kg per hour na production rate tsaka 12% acetic acid na concentration. Target itong mga to. Gusto natin must produce itong mga values na ito. Okay? In other words, if you want to figure out kung ano yung kailangan mong ipasok na feed, whatever those substances are, ang makakalculate natin dito is yung pinaka-minimum. Okay? So kapag sumobra sa minimum, therefore magkakaroon ka ng conversion ng iba pang relationships, right? But before that, ano pala yung pinapasok natin sa feed? Okay? So, syempre, kailangan natin sa feed ng ethanol kasi siya yung carbon source or yung reactant sa ating reaction. So C2H5OH. Okay? And then, well, we have to usually si ethanol, naka-solution naman siya, di ba? So kailangan may water din tayo. Okay? Now, let's introduce some variables. Okay? So sabihin natin N1 si ethanol, N2 si water, N3 si oxygen dun sa off gas, and N4 si nitrogen. So yun lang naman yung mga unknowns natin. So back to my point earlier, we would like to know how much ethanol and water ang kailangan, okay? Must have or kailangang ipasok. Okay, para ma-produce mo yung target na values na ito. Okay? So, in other words, what we're going to assume here is 100% completion. Okay, kasi hindi pa nangyayari tong process na to. Target pa lang. So, if we have 100% completion, ibig sabihin, ang makakuha natin na value ni N1 and N2 ay yung mga minimum values. So, of course, in reality, kapag ginamit na itong process na to, okay, to produce acetic acid, so pwede mong sobrahan yung N1, pwedeng sobrahan yung N2, or pwede mong babaan, depende, no? But if you did that, magkakaroon na tayo ng conversion, ng yield, etc. Pero since hindi pa nangyayari itong process na to, well, 100% completion yung assumption natin. Okay? So let's proceed further. So mayroon tayong business na 1 hour operation, pero ano yung mga values na pwede na nating mahanap before solving using molecular balance? So let's start with the air properties, air composition. Okay. We know that yung air, di ba, ang pinasok na air, according to the problem, is 200 moles, okay, per hour. So since nag-base na tayo ng 1 hour, 200 moles na lang siya. So from that alone, makukompute na natin yung amount ni oxygen na pinasok, okay? Hindi ito yung amount na oxygen sa off gas, but rather yung amount ni oxygen na pinasok. So alam natin na 21%. Okay? Yung composition ni oxygen dun sa air, so that will become 42 moles or gram mole. Paras lang yan. And then si amount naman ni nitrogen is just the difference, right? 200 minus 42, or you can actually compute it using this factor, 79% of 200. So that will become 158 moles. Okay? So alam na natin agad yung composition ni air na pinasok dun sa ating fermentor. Okay? Next, let's consider the product composition. Kasi kung napapansin nyo, mahanap na agad natin yung composition or amounts kay product stream kasi sila yung target eh. Ang unknown talaga dito is yung feed. So for product, we don't know how much product total ang meron dun sa stream na yon. So kung babalikan natin yung ating stream or ating flow sheet, ang total amount ni product ay we use the symbol P. Okay? So gaano daw karami yung P? So remember, ang production rate is 2 kg acetic acid, hindi 2 kg of P. And meron ka din naman dito ang concentration ng acetic acid na 12%. So in mathematical terms, pag sinabi natin product composition, ang 12% daw ng P ay yung amount na target natin na acetic acid. Okay? So therefore, makukuha natin kung gaano kadami yung P, which is 16.67 kg. Ibig sabihin yan, yung 16.67 kg na yan, 2 kg dyan yung acetic acid. Okay? Kasi siya yung target production acetic acid natin. And the rest will be water. Okay? So if we will tabulate it, okay, we have here acetic acid and water. Okay, tabulate lang natin. Acetic acid, di ba, 12% daw yung concentration. So the rest, meaning 88% yung kay water. Okay? So sa acetic acid, 2 kg daw. So in terms of mass, 2 kg. Paano naman yung water? Okay, so therefore, amount of water in P is simply the difference, 16.67 minus 2 kg. So that will become 14.47. So 14.67 kg. Okay? Or pwede mong gawin 88% of 16.67 kilograms. Anyway, we need also the molar amounts. Okay? So in terms of moles, N, so what you have to do is to convert yung 2 kg of acetic acid into moles. So kapag sinabing moles, okay, yung 2 kg magiging 33.33 moles. Okay, so of course you have to convert kilogram muna to gram and then use the molecular weight to convert it to moles. Or yung kilogram pwede mong gamitan ng molecular weight to convert it to kilomoles and then from kilomoles to moles. So kayo nang bahala mag-compute dyan. And then for water, the amount in moles will be 803.89 moles. Okay, so we will need these values later on. Now, wala na. Tapos na tayo sa air composition. Tapos na tayo sa product composition. The rest will be unknown already. So, you have to proceed now to species balance. Okay. Now, ano ulit yung equation? So, let me write it again. Okay. Moles input plus moles generated equals moles output plus moles consumed. Okay, hindi ko na sinama si accumulation kasi we are assuming here that steady state yung ating process. Okay, so pag sinabi natin molecular balance or species balance, literally, bawat species gagawa natin ng balance. Okay, now, saan tayo magsisimula? Well, you can start with any compound. Pwede, walang problema. Pero siguro maganda din naman na magsimula tayo sa tie component. Okay, so ano ba yung tie component? Yung tie component in this example is yung nitrogen. Ibig sabihin kasi nitrogen that goes in the process or into the process and that goes out into the process since si nitrogen hindi siya nagpa-participate sa reaction. So parehas lang yung amount na yun. So let's write it this way. So nitrogen balance. Okay? So kaya species or molecular balance tawag niya kasi yung balance na ginagawa mo per molecule, hindi siya per atom. Okay, so ilan ba yung input natin na nitrogen? Okay, so start tayo sa moles input. Well, ang nilagay natin na nitrogen is 158 moles. Tama ba? 158 moles. Kung babalikan lang natin saglit yung ating air composition, ito siya, yung 158 moles na pinasok natin dun sa fermentor. Okay? Plus moles generated. Okay. Ano ibig sabihin yan? So, si moles generated, siya yung species na napoproduce in the process or in the reaction. But nitrogen is not a product of the reaction. So, kung babalikan ulit natin yung reaction dito kanina, sana siya, which is this one, right? Nitrogen does not appear either sa product side or sa reactant side. It does not participate in the reaction. So, wala kang moles generated. So, 0. Equals output ni nitrogen. Meron bang output of nitrogen? So, meron, di ba? Kasi in-assume natin na sa off gas, merong oxygen, merong nitrogen. Okay? May lalabas na nitrogen malamang. Okay? So, ano yun? Ano yung amount ni nitrogen sa off gas or yung lalabas na nitrogen? Ayun, no? N4. So, unknown siya, right? N4 siya. So, ilagay natin dito, N4. Plus, moles of nitrogen consumed. Walang ganon. 0 siya kasi hindi nga siya nagpa-participate sa reaction. So, 0. So, this equation alone, nakuha na natin agad that N4 is equal to 158 moles of nitrogen. Okay? So, yung 4 unknowns natin, na-solve na natin yung isa, 3 na lang. Okay, so let's just continue with the rest of the balances. So, let's have maybe acetic acid balance. Okay. Input of acetic acid. Meron ba tayong pinasok na acetic acid? So, wala. 0. Generated acetic acid. So, malamang meron yan kasi product si acetic acid dun sa reaction. So, number 1, acetic acid participates in the reaction. Number 2, product siya dun sa reaction. Okay? So, therefore, meron. Hindi lang natin alam kung gaano kadami. Now, don't be confused. Bakang ilagay yung moles generated acetic acid is yung nakuha natin dito sa product composition. So, hindi ito. Not this one. Okay? Hindi yan. Yan yung output ni acetic acid pero hindi siya yung generated acetic acid. Okay? But later on, tingnan natin baka paras lang sila. So, paano natin mahanap yan? Okay? So, unknown pa siya. So, N gen acetic acid equals output acetic acid, do we have that? Ito yung 33.33. And consume acetic acid participates in the reaction, yes, pero hindi siya nako-consume kasi hindi naman siya reactant doon sa reaction natin. So, 0. So therefore, may nakuha tayong mahalagang number dito which is yung generated acetic acid, 33.33 yan. Hindi siya kasama sa mga hinahanap natin pero kailangan natin siya. Okay, since meron ka na nitong generated moles of acetic acid, pwede mo nang mahanap yung generated na ibang product and yung consume na ibang product. So what do I mean? If we are going to write again the reaction, so which is C2H5 COOH, tama, plus oxygen forming acetic acid plus water. Okay? Na-solve natin kanina yung generated acetic acid. So, ilalagay ko lang siya dito sa baba, 33.33. Again, this is not the output, but rather the generated moles of acetic acid. Now, use this value for the rest of the species, right? So, therefore, kay water, 33.33 kasi 1:1 lang naman yung relationship nila. Ganoon din naman kay oxygen at kay ethanol. Oops, mali yung formula ko ng ethanol. Sorry. That should be OH. 33.33. Okay? 1:1 lang kasi yung relationship nila. If merong stoichiometric coefficients, mababago yung answer natin, syempre. Or mababago yung values. Now, ituloy natin yung species balance natin. So, let's go for, so tapos na tayo kay nitrogen balance and acetic acid balance. Mag-water balance kaya muna tayo. So, water balance. Okay? Input plus generated equals output plus consume. So, input muna tayo. Meron ba tayong input ni water? Okay? So, tandaan lang ninyo yung formula na to. Okay? So, input ni water. Do we have an input of water? Okay? So, if we go to the flowchart here, input ni water, yes, we have. We need to find that out. So, N2 ang input ni water. So, unknown siya. Plus generated water. Meron bang generated water? So, if you check the reaction, ayun, no, meron. Water is being generated in the reaction. So, ang tanong, gaano kadami? Ayun, no, alam na natin agad, 33.33. Plus, equals output of water. Do we have that? Input na nga siya, output pa siya. Yes, di ba? So, if you go back to the flow chart, water is also on output. In fact, we have a tabulated product composition here. So, water is also an output. And ilan? Gaano kadami? 803.89, right? So, ilagay natin yan. 803.89. Okay. Plus consumption of water. Yan ang 0 kasi water is not a reactant in the reaction. So, wala siya dito sa reactant. Nasa product lang siya. So, isa na lang ang unknown dito. N2 na lang. And the answer here, if you do the calculation, is 770.56 moles of H2O. Okay, let's do the rest. Oxygen balance. Input of oxygen is 42 moles plus output plus generated oxygen moles rather, that's 0 because oxygen is not being generated in the reaction. Equals output of oxygen, di ba yun yung ating unknown na entry sa off gas? And consumption ni oxygen, meron, ayun no. It's being consumed in the reaction. And we know the value already, 33.33. So therefore, N3 will become 8.67 moles of oxygen. Isang unknown na lang. So, si ethanol balance na lang tayo. Ethanol balance, input na ethanol, N1. Plus generated ethanol, wala. Hindi siya product dun sa reaction eh. Output ethanol is ilan? Diba meron tayo yung kanina? Output of ethanol, sorry, wala pala. Okay? Walang ethanol na lumalabas sa process. Kasi nga, nag-assume tayo ng 100% completion. Not really assume kasi 100% completion dapat talaga kasi again, we are designing the process pa lang. Okay, so 0 siya. Plus consumption ni ethanol, meron, di ba? 33.33. So therefore, N1 is 33.33 moles of ethanol. There, we have completed the balances. We have calculated the 4 unknowns. Sagutan na lang natin yung mga tanong. Okay, so letter A, ang tanong doon is minimum amount of ethanol required. So, paano yan? Ano ba yung ethanol? Ayun no, 33.33 yung sagot, di ba? Yung N1. Pero gusto kasi natin dito siguro ay in terms of mass, di ba? Or kilogram siguro. So that's 46 gram per mole. Okay? Convert natin siya sa kilogram. So 1,000 gram ang isang kilogram. Therefore, ang sagot dito ay 1.533 kilogram of ethanol. Yan therefore yung required amount in kilograms ni ethanol na kailangan mong ipasok doon sa process to obtain the desired productivity and concentration of your acetic acid. Okay? So pag binago mo yung amount na yan, malamang magkakaroon ka ng mga conversion and other parameters. So this is the answer. Now, let's go to letter B. Ang tanong doon ay minimum. So, di ba, puro siya minimum kasi nga 100% completion. Amount of water used or required. Eh, ano ba yung amount ni water? Nasaan siya? N2, this one. Okay, 770.56. Convert natin. So, using the molecular weight, it's 18. Tapos, divide natin ng 1,000 para maging kilogram. So, sagot dito ay 13.87 kilogram water. Ayan. So, usually, pinapasok yung ethanol as a solution. So, therefore, alam mo na kung ilang part ethanol, ilang part water because you know the values here already. Okay? By the way, this is per hour. Okay? Per hour. Per hour. Kasi, nag-basis tayo kanina ng 1 hour operation. Okay? Next, letter C. Composition of gas. Ano daw yung composition ni nitrogen and oxygen? Ano yung mga percentage nila? Hindi sinabi kasi kung by weight ba or by mole. So, gawin na lang natin lahat. So, oxygen. So, this is components of stream G, di ba? Yung off gas natin, stream G. So, meron tayong oxygen, meron tayong nitrogen. Yung kanyang moles, 8.67. Ito yung mga nakuha nating sagot kanina from the molecular balance, and 158. Okay, so moles to. Gusto natin makita yung mass in terms of, ano ba to? Gram na lang, no? So, paano yung i-convert sa gram? So, i-multiply mo na lang ng kanyang molecular weight. So, magiging for oxygen, 277.44 grams. And kay nitrogen, it's 4424 grams. Oops. So, add mo yan. Ang total in terms of mass is 4701. Yung kay mole kanina, gawin din natin yung total. That's 166.67. Okay, so therefore percent by moles tsaka percent by mass, malalaman na natin. So percent by mole is yung 8.67 kay oxygen divided by the total. So ganoon din gagawin kay nitrogen. By weight naman, you will use yung grams. So doing that, you will get 5.20% for oxygen and 94.8% for nitrogen. Pero in terms of mass naman, it will become 5.90% by weight and 94.1% naman yung kay nitrogen. So that is how you solve a reactive process or a material balances involving reactive processes using the molecular balance method.